notes. It talks about graphs of exponential functions. So first we're just going to review how to write an exponential function. There's two ways. Y equals a times b to the x. And remember, a is your y-intercept. It can also be thought of as the initial value. All right, if you were, doing a word problem, all right, it would be the initial amount you started with. All right, and b will tell you growth or decay, whether you have exponential growth or decay. All right, remember, growth happens when b is bigger than 1. All right, decay happens when b is between 0 and 1. All right, so let's say, for example, all right, if we had something in the form y equals 3 times 0.6 to the x power. All right, that means 3 is our y-intercept. 0.6 is a number between 0 and 1, so this would be exponential decay. All right, another way to write the equation, all right, is y equals a 1 plus r to the x power, or really 1 minus r. All right, depending on if we have exponential growth, it would be plus r. If it was exponential decay, it would be minus r. And really the whole positive to this format is to know how much it's growing or decaying by. All right, it's not obvious in this a times b to the x format how much it's decaying by. A lot of kids think, oh, that's decaying by 60%. That is not the case. All right, that is why you should rewrite it in this other format. So this same example right here, if we were to rewrite it, we'd still have 3 as our y-intercept. All right, but think since this is decay, it's going to be 1 minus something. All right, and think you got to figure out what's that number. 1 minus what will get you 0.6? You could probably do it in your head. 0.4. Hopefully you guys agree. 1 minus 0.4 is the same thing as 0.6. All right, so this is really the same equation, but writing it this way really tells you, because you're subtracting, that means it's decaying by, and that 0.4 you just turn into a percent, it would be decaying by 40%. All right, so this y equals a 1 plus r or 1 minus r to the x power, it gives you more information about what it's actually decaying by. All right, so let's take a look at example 1. It says graph y equals 2 to the x plus 0. So first of all, we're used to used to thinking in terms of y equals a times b to the x. So we have y equals 2 to the x power. We have that b to the x part, but we need to figure out what's that a value in front. All right, if there's no number, you could put a 1 there, right? 1 times anything doesn't change, the value. All right, so that would mean 1 is our y-intercept. All right, or in other words, 0, 1. All right, 2, this b value, that's bigger than 1. That would tell us we have exponential growth. All right, something else to point out, the number added onto the end. We don't have a number on the end, so we could put a plus 0 there, but that's always your horizontal asymptote. So we could say we have a horizontal asymptote at y equals 0. All right, so these are the things that we need to include on the graph. So our y-intercept is 0, 1. Let's go ahead and plot a point there. Our horizontal asymptote is at 0, so make sure it's dashed. You should always label it, right, that's at y equals 0. And then we said it was growing, so growing would look something like this. All right, it's truly just a sketch. But on the left side, you should get closer and closer to the asymptote. On the right side, it should be growing, going up. So that's how you could sketch a graph of 2 to the x power. All right, let's take a look at example 2. So we kind of have to narrow this down. All right, we can look at first probably y-intercepts, and then we can kind of go from there. So there's a bunch of y-intercepts that are 3. All right, so 3 is probably this y-intercept that has a bunch of graphs going through it. All right, then we've got a y-intercept of 4 and then a -3. All right, so I think the y-intercept of 4 is probably the higher one. That probably has to be a. All right, that would make sense. The 1.2, that's bigger than 1. That would be exponential growth. So graph A is definitely growing. All right, so we did graph A. I might just even cross that out. We got that one. All right, with this -3, a y-intercept of -3 would probably be down here. This looks like decay, but really F is growing. So let's just remember how we kind of figured out what the graph of those look like to begin with. We kind of ignored the negative. We said, first kind of think, what would y equals 3 times 0.7 to the x power look like? Right, if you were just going to sketch a graph of that, you'd have a y-intercept of 3, all right, and 0.7 would be decay. It would look something like that, all right, but then we said, if you threw a negative in front of it, like up here, the negative is a reflection over the x-axis, all right, so it would be really the opposite, something like this, all right, so that would have to be F. So maybe write yourself a note about that. Negative is a reflection over the x-axis, if that negative is really just thrown out in front. All right, so we can kind of cross out F2. We use that one. All right, so the rest of them, kind of hard. We need to narrow it down. So first, I would just write a few things we know about each equation. All right, this first one is decay, because 0.7 is in between 0 and 1. 0.8 is also decay. 1.2 is growth. All right, and 1.4 is also growth. So they all go through this y-intercept in the middle. All right, so for the two that are growing, that's going to be B and C. Those two are going up. All right, so we need to narrow it down. All right, think about what they're growing by. All right, you can probably just think about how much bigger than 1 that number is, 1.2. 0.2 bigger than 1, that's growing by 20%. All right, whereas this one, 0.4, it's growing by 40%. So the one that's growing by 40%, right, I think that would have to be B. That one ends up on top. That's growing faster. So the 40% would have to be B. We can cross that off our list. And then C is growing a little bit slower. It ends up a little bit under B, so this one would have to be C. All right, so right now we're narrowing it down between our two that are decaying. All right, that's D and E. And we have to think about how much they're decaying by. All right, the first one, is not decaying by 70%. The second one's not decaying by 80%. You have to think how much less than 1 are those. So you could rewrite those as 1 minus something. All right, but you really got to think in your head, 1 minus what would get you 0.7? It'd be 0.3. All right, and the whole point of rewriting it like that, that's decaying by 30%. All right, and the other one, all right, we could rewrite that as 1 minus 0.2 to the x power, right? 1 minus 0.2 is the same thing as 0.8. That's decaying by 20%. All right, so think the decaying by 30%, that's going to be decaying quicker. That's going to go straight down faster. All right, so that's going to be your graph E. It ends up lower. That's decaying faster. So decaying by 30% would be graph E, where D is decaying a little bit slower. It ends up on top. So that would be the decaying by 20%. So that's kind of how you can narrow it down. Yes, it is kind of a matching problem, but it does take a lot of thinking there. And it can't hurt to kind of write yourself little notes to help you get through it. Exponential growth or decay, the horizontal asymptote, and sketch the graph. That all seems easy. And then it says describe the end behavior using limits. That's the new part. All right, so we'll talk about that second. But let's do kind of all those first few things that they asked for. So identify the y-intercept. Well, 3 is our y-intercept. So y-intercept is 0, 3. Right, they said exponential growth or decay. 2 is bigger than 1. So we're going to have growth. All right, the horizontal asymptote. Remember, that's the number added onto the end if there is no number. That's a 0. So our horizontal asymptote is at y equals 0, and then it says to sketch the graph. So let's do the horizontal asymptote first. Should always label it y equals 0. All right, our y-intercept is at 3, and we said it's growing. All right, that would be a sketch of the graph. All right, let's do part B as well, and then we'll go back to the second part, describing end behavior using limits. Right, so in part B, all right, 4 is our y-intercept. So y-intercept is 0, 4. 0.6 is between 0 and 1, so that's exponential decay. And then that number added onto the end, that plus 1, that's your horizontal asymptote. We have a horizontal asymptote at y equals 1. So let's start by graphing that at y equals 1. Should always label it. And then our y-intercept is 4. And we can do decay. Decay would look something like this. Again, it just has to be a sketch. All right, so the next part is describe the end behavior using limits. And I think this is going to be brand new to you guys. I don't think you've ever seen limits before. All right, so limits, when we're describing end behavior, it's really talking about the left and right side of the graph. Where are they going? All right, so first let's talk about how to write the limits. All right, we're going to talk about the limit as x approaches negative infinity of the first one is called f of x. So we'll put that function there. Basically, that's how you write it, and we want to come up with what it equals, an answer. All right, limit is spelled out LIM. It's abbreviated. Directly underneath it, you should have x with an arrow to negative infinity, and then you should always have the name of the function f of x. So we're going to figure that limit out. All right, and then we're also going to figure out one more limit. It's the limit as x approaches positive infinity of f of x. So those are our two limits we need to figure out. The first limit, the limit as x approaches negative infinity. That basically means on your x-axis, as you get more and more negative. So think on your x-axis, if I started in the middle and I traced and got more and more negative, it'd be going this way. All right, so that's what we're doing, but instead of tracing on the x-axis, trace on the actual graph. If you start in the middle of the graph and you go more and more negative, it's where is this function going? This function is getting closer and closer to my asymptote, and my asymptote is at 0, so my answer is 0. All right, in other words, this is a fancy way of saying basically where is my left side of the graph going? Left side of the graph is getting closer and closer to the asymptote. The asymptote is at 0, so the answer is 0. All right, the next limit as x approaches positive infinity. All right, that one, that's a fancy way of saying where's the right side of my graph going. Think as x gets bigger and bigger and goes to positive infinity. All right, so this one, I would always start in the middle and just kind of trace it. And as I trace to the right, where is my graph going? It's going up to an arrow. If your graph is going up, it's going up to positive infinity, and the answer is positive infinity. All right, one thing to point out with this limit notation, try to write it exactly as I did. All right, this is not really the time to put your own spin on things. All right, this is kind of the universal notation, how you write it. All right, again, don't put anything in a different spot. You know, this word LIM, directly underneath it should be x with an arrow to negative infinity, and then the name of the function right after it to the right. All right, so try not to put your own spin on that. All right, so for the next one, same limit notation. We're going to do the limit as x approaches negative infinity, all right, of, I think this function is called g of x, so you got to use the right name of g of x. We got to figure out what that equals. And then also the limit as x approaches positive infinity of g of x. Again, all this is a fancy way of saying what is the left side doing, all right? Negative infinity basically means the left side. All right, and the second limit is a fancy way of saying what is the right side doing. As x approaches positive infinity, that's what's the right side of your graph doing. So let's first start with the left. if we start in the middle and we trace to the left, our pen is going up, 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 up to infinity. So the answer would be positive infinity. All right, if we trace to the right for the second limit, starting in the middle, and we trace to the right, we're getting closer and closer to the asymptote. The asymptote was at 1, so the answer is 1. Let's take a look at part C. Y equals 6 times 1.4 to the t power minus 2. Again, same thing. We're going to graph it, and we're going to find the end behavior using limits. All right, so our y-intercept is 0, 6. All right, 1.4 tells us this is exponential growth. And then your horizontal asymptote is at y equals negative 2. All right, so let's start graphing that. Y-intercept at 6, horizontal asymptote at negative 2. So y equals negative 2. And then we said we have growth. So maybe something like this would be a sketch of the graph. And then we have to do our limits. So we have the limit as x approaches negative infinity of our function's name here is y. All right. So I guess we could put a y here. And then also we could set up the limit for the other side, the limit as x approaches positive infinity of y. So I think the first one's a fancy way of saying what's the left side doing. Second one is a fancy way of saying what's the right side doing. All right, so we need to first start tracing from the middle to the left. As I trace more and more to the left, I get closer and closer to my asymptote. My asymptote is at negative 2, so my answer is negative 2. All right, for the second limit, it's a fancy way of talking about the right side of the graph. If I start in the middle, usually the middle is the y-intercept. If I trace to the right, my pen goes up. Up is positive infinity, so my answer is positive infinity. All right, let's take a look at the challenge. It says, describe the end behavior using limits. So again, let's just set up our limits. We have the limit as x approaches negative infinity of, let's give this function a name. It doesn't have a name. What if it was called r of x? So that would be the left side. And then the limit as x approaches positive infinity of r of x would equal the right side. So we got to find these two answers. All right, and one thing to point out, we do have an asymptote here. All right, this asymptote wasn't labeled, but it's at y equals 3. So I'm just going to label that. All right, so the first limit as x approaches negative infinity. That is if we trace from the middle to the left. As we go further and further left, our pen is going down. Down would be negative infinity. And then the other limit is a fancy way of saying the right side of the graph. If we trace from the middle to the right, we're getting closer and closer to the asymptote. The asymptote is at 3, so our answer would be 3. All right, I hope you guys found these notes helpful. If you have questions, contact your teacher. Otherwise, you can get started on the homework for tonight. Have a great day, guys.